This is Mr. Beck Does Your Homework. This is AP Physics, Homework 9.1, question number 10. A DNA molecule is 2.44 micrometers long. Well, the micro here works just like microcoulombs, so that I know that my distance, I know later I'm going to get to a distance, is going to be 2.44 times 10 to the minus 6th meters. The ends of the molecule become singly ionized so that there is negative 1.6 times 10 to the minus 19th coulombs on one end and positive 1.6 times 10 to the minus 19th coulombs on the other end. So I've got this DNA that's got a positive on one end and a negative on the other end. Well, this positive and negative are going to attract each other, and this thing is going to shrink a little bit and act like a spring. The helical molecule acts as a spring and compresses 1.30%, compresses that much upon becoming charged. This compression is my x in my F equals K X spring equation. This K is spring constant. Don't get that confused with my electric Coulomb constant, because now I'm talking about a spring. Since we usually don't see the two together, they weren't worried about having the same variable in both. So X here is how much it compresses. Well, X is going to be, for me, 1.3%. That's 1.3% of my length of the molecule, which is 2.44 times 10 to the minus 6th meters. So I've got 1.3%, or 0.013 times this number will give me my x for F equals Kx. Find the spring constant. So I'm solving for this K. Well, what's the F? Well, that F is going to be the same as the Coulomb constant F. So I know that the force between them is going to be the Coulomb constant K times the first charge times the second charge, both of which are the same, so really I could just say Q squared over R squared, and here's the R that I'm dealing with. 2.44 times 10 to the minus 6th meters is how far apart they are. So I know that this F and this F are the same. So you could do some algebra to get rid of things, or just do it easier. Solve for this force, plug that force here, divide by your X, and you'll get your spring constant of the molecule. And if you're doing everything in terms of meters, this will be meters and these are coulombs and such, you're going to wind up with a spring constant in newtons per meter, standard units.